Okay. Hello, my name is Bryce Walburn. Today I'll be talking about the Papermate Clearpoint mechanical pencils. So that's pictured one there in case you don't know what it is. So we're going to be talking today about the three main polymers that I selected from the mechanical pencil. So the first is going to be the outer polystyrene cylinder. So this is going to be the clear plastic that you can see through. It's a very rough, more brittle plastic, I'd say. And then you have your writing lead, obviously the graphite that we all know that you write with on paper, and then the rubber eraser that you use to erase whenever you make a mistake, obviously. So getting into polystyrene, again, that outer cylinder part first. So polystyrene, it's a polymer of styrene, as the name suggests. The molecule here is, this is the monomer, so it's ethane fused to a benzene ring. The melt temperature is 410 to 480 degrees Fahrenheit, so relatively common compared to other plastics. And then it appears in two forms, so clear hard plastic I'm going to talk about today, and we'll give other examples later of spots you probably know in your everyday life. And then the soft white foam that we know as styrofoam was trademark name for polystyrene foam. So how you make styrene from the base products of ethene and benzene. So again, start with your starting materials. You're going to bond the ethene to the benzene and make this ethyl benzene group. And that's kind of the bare bones of the monomer, but in order to polymerize it, you need to make that double bond present so that you can actually have something for the other monomers to bond to. Otherwise, your carbons here wouldn't have any more action. So you then pull the H2 group off of the ethyl group, and you make this styrene molecule, monomer. So now you have your styrene monomer. How do you make polystyrene from this? You take your monomer's small amount of peroxide and disperse it into water. And then with the help of surfactants, you heat the solution up, and this helps kind of coagulate all the monomers together, and the heat helps them form those bonds to polymerize it. And then you get 1 to 5 millimeter diameter beads of polystyrene. So again, as mentioned earlier, I was going to talk about the forms of polystyrene that we have. So the ones used in this mechanical pencil are going to be, I'm going to call it the normal plastic type. So it's produced similarly to other plastics. It's manufactured, it's used similarly to other plastics. You can make clear to-go boxes like I've seen from some restaurants, or a CD case, or any other, just anything. Anytime you see like this hard, clear plastic, it's probably going to be a polystyrene. And then your other form of polystyrene I mentioned that we know as styrofoam is when you blow gas into polystyrene when it's forming, and that forms that foam layer. So obviously, like your to-go coffee cups, you get a lot of times it's styrofoam, or a lot of times to-go boxes, egg cartons. I feel like everyone kind of interacts with styrofoam on a daily basis as well. So the next polymer I'll be getting to for the mechanical pencils is our writing lead. These are hexagonal rings fused together. So the molecular structure is here to the right. So it's basically every carbon is double bonded to another carbon and then single bonded to two others. That bonding pattern forms 120 degree bonding angles for every carbon. And so because of that, it stays two-dimensional, and it doesn't, it's not a 3D crystalline structure, which graphite, or graphene I should say, was one of the first compounds to be known with a flat molecular structure, or flat crystalline structure. And it's probably one of the most common ones we use today. And then side note as well, so one layer of this molecule is graphene, and when you combine the layers together, it forms graphite at roughly 30 layers, which I feel like graphite's more the name that we know it by. And then the single layer property of the graphite piece allows for the writing lead to actually write easy. So as you're moving the lead across a page, it can kind of shear off one layer at a time and allow you to write and allow the lead to come off. So how to produce graphite? Not many pure graphite deposits necessarily exist, so it's not something you just mine out of the earth. you usually have to do some manufacturing with it. So, like a lot of polymers, you start with crude oil or natural pitch. In this case, you use the crude oil distillation residue, and then you heat it anaerobically or without the presence of air. This process produces a few products, but the ones we're focused on is the good coke of that anaerobic heating. Then you mix that with more hot pitch. This mixture is basically graphite at that point. You extrude it to the rough desired shape that you want, and then at 3,000 degrees Celsius, a current is passed through, and it locks the graphene crystalline structure in place and locks that graphite piece together. So going on to our rubber erasers now. So we've talked about rubbers a few times in class. So synthetic rubber is made from the copolymer of styrene butadiene. And then how an eraser works, I guess, to actually erase pencil lead is that friction between the eraser and paper is what pulls that lead off of the page, and allows for that single layer of graphene to come off. So making the monomers styrene and butadiene, we already talked about styrene. So here again, you're just going to make the monomer styrene. To make butadiene, you have to start with a mixture of a bunch of hydrocarbons. You superheat, or you mix it with steam and superheat that mixture, and that creates a bunch of alkenes of different, again, so you could have a hexene in there or an octene or something. So any hydrocarbon in there. And then basically through the distillation, through the different boiling points, you're able to kind of extract every alkene as you need. So butadiene is one of those products, which, if you don't know, butadiene is this molecule off to the right here, so 4 carbons, 2 double bonds on the end. So making styrene butadiene copolymer, so it's a relatively similar process to making polystyrene, but you mix the 2 monomers in water together, mix it with a little bit of peroxide again, and some surfactants. After that, you heat the solution, as like we said before, and this forms very, very small latex particles, which are your copolymer. So now you have a copolymer, but you make it into a usable rubber eraser, one that's probably long-lasting, good at picking up pencil lead, all that stuff. So you have your copolymer, you mix it with a few other ingredients, and mainly sulfur is the big key. So once you heat that mixture, the sulfur vulcanizes the rubber, or it makes it a lot stronger. So this is going to increase the lifespan of the rubber. It's going to help it erase things easier because it's going to be tough. And then once you have the rubber and the properties that you want from it, you're going to extrude it as a soft solid through a die, and it creates a cylinder shape. So this is a little schematic of how you could make a pencil top eraser, similar to what I'm talking about today. So you have your copolymer mixture, it's already been vulcanized, it's up in this hopper, and you extrude it through a circular die, and that makes this long cylinder. Then as you go down the line, you just have a knife come and chop it at pre-measured intervals, and that's going to make your little cylinder erasers. If you wanted, for instance, to make a block eraser, one of the bigger ones, instead of this being a circular die, you could have it be a rectangular die, and again, that knife can cut it either straight up and down, or like the ones I see a lot are more angled, but again, a very similar process, just a different die shape. All right, and any questions? Thank you for listening.